Indicate the true statements, rewrite the false ones correctly. Acceleration is due to a change in the speed regardless of direction. False. Acceleration is due to a change in the speed and or the change in the direction of motion. So if you have a change in the speed, this means that we have a change in the velocity. And if you have a change in the direction of motion, this means that we have a change in the velocity too. And acceleration by definition is the change of velocity with respect to time. So if either one of them changes, then there is acceleration. Now an object at rest has zero acceleration. This is true because the speed doesn't change. The speed is zero all the time, and also there is no motion, there is no change in the direction, so no motion means zero acceleration. Now two cars A and B moving at 60 kilometers per hour side by side in the same direction have the same speed but opposite velocities. This is false. Two cars A and B moving at 60 kilometers per hour side by side in the same direction have the same speed and velocity. An object that covers the same distance during the same intervals of time moves at a constant speed. This is true. Covering the same distance, like every 2 minutes the object covers like 2 meters. Every 2 minutes the object covers 2 meters. This means that the object is moving at a constant speed. It's not increasing its speed. Otherwise, it would have increased the distance covered if the speed was increasing, or if the speed was decreasing, the distance would be less than 2 meters because the speed is decreasing. So this is not true here. We have same distance covered, same speed. Exercise 2. A car travels from point A to B in 3 hours and return back to A in 5 hours. Point A and B are 150 kilometers apart along a straight highway. Calculate the average speed of the car during the whole 8 hours. So the total distance covered in this case is 150 kilometers plus 150 kilometers, because as the car goes from A to B, it covers 150. Then from B to A, it covers also 150. So together they are 300 kilometers. And the total time is 3 hours plus 5 hours, which is 8. Now the average speed is total distance over total time. So this is d over delta t. 300 kilometers over 8 hours is 37.5 kilometers per hour. Now Ben is running at a constant velocity of 3 meters per second to the east. So constant velocity means same speed, same direction all the time during the time studied. How long will it take him to travel 720 meters? So V average is d over delta t, then delta t is d over V average. It's equal to 720 meter over 3 meters per second equal to 140 seconds. Now, when you are given that Ben is running at a constant velocity of 3 meters per second, this means that at each instant Ben was running at this speed. So you're given the instantaneous speed, but because it is a constant speed, and we know that in uniform rectilinear motion in which the speed is constant and the pathway is a straight line, V average is equal to V instantaneous. So we can say here that V average, we can use this, the formula of average speed. Okay, so delta T is D over V average, which is 720 meters over 3 meters per second, 240 seconds. Now exercise 3. A swimmer swims in a straight line in a pool from one end to the other end where she stops. So the pool when she goes from one end to the other end, she follows a straight pathway, and the adjacent graph shows the variation of the distance covered by the swimmer as a function of time. Now 1. Determine graphically the time needed by the swimmer to cross the pool from one end to another. The key for the answer here is that she stops at the other end. And when we are given d versus t, in which the distance reaches a point and that becomes constant, so this means that no further distance is covered. That's why this means that the swimmer stopped at this instant, because she did not cover any further distance later on. So when the swimmer stops, no further distance is covered, d becomes constant, then the time needed by the swimmer to cross the pool is 4 seconds. Now determine the length of the pool. During this 4 seconds, she covered a distance of 2 meters, which is the length of the pool. 3. Calculate the average speed of the swimmer during the first 4 seconds. So the average speed is equal distance over total time. It's 2 meters over 4 seconds. This is 0.5 meters per second. 4. Deduce her instantaneous speed at t equal 2 seconds. Back to the same point that I mentioned in the previous exercise. Because Now, d versus t graph is an increasing straight line. You have to memorize this because d is versus t is an increasing straight line. Then the motion is URM. What do I mean by URM? Is uniform rectilinear motion, which means that the speed is constant while the object is moving on a straight line, rectilinear pathway. So in this case, we have that the average speed is equal to instantaneous speed. So whether we calculate the average speed during the whole time or we check it during or at each instant, we find that it's the same. So V average is V instantaneous. So نحن in part 3 we calculated V average. Now in part 4 we deduced أنه V instantaneous is equal to V average which is equal to 0.5 meter per second. Because this instant, which is 2 seconds, belonged to the interval of time in which we calculated the average. So at each instant here the speed is equal to the average speed. Now exercise 4. The speed of a train at different instants is given in the table below. T equals 0, V0, 6, 5.4, 12, 10.8. So here we're given the instantaneous speeds. We are supposed to draw the graph and given the scale. Draw the graph representing the variation of the given speed as a function of time. So we have the speed on the y-axis and the time on the x-axis. Okay. First of all, don't forget to write V and the unit, T and the unit. Title the variation of the speed as a function of time. Okay. Now, how to locate the points? We have to divide the given values by the scale. Now, 0, 0 is known here. Don't forget to join the graph to this point. It's important. It's given. Then you have to join it. Then you have 6 over 6 is 1. So you go 1 centimeter horizontally on the x-axis. 12 divided by 6 is 2. So you go 2 centimeters. 18 divided by 6 is 3. So you go 3 centimeters. 18. 24 divided by the scale of time, which is 6. 24 by 6 is 4, so you go 4 centimeters away from the origin. 30 divided by 6 is 5 centimeters, so you go 5 centimeters away from the origin. Now vertically you do the same thing. You have to divide 5.4 by 3. Then it's 1.8 centimeter above the origin. 10.8 by 3. 10.8 by 3, if you do it on the calculator, this is 3.6 centimeters, so you go upwards above the origin by 3.6 centimeters to locate 10.8. 16.2 divide by 3, the same thing. Okay, then you go locate, check the time and the speed for each one and locate the points and you join them. You obtain an increasing straight line as you can see here. Now, based on the shape of the obtained graph, determine whether the acceleration of the train is 0, positive constant, or negative constant. Now, because V versus T is an increasing straight line, then the speed is increasing at a constant rate. Thus, A is positive constant. And I want you to go back to refer to this table. Okay, you have when D versus T is an increasing line, V is constant, A is 0. When D versus T is a parabola and V is an increasing line, then A is positive. Okay, so you have to memorize this table. When D versus T is also a parabola, but in this way, in taking this shape, and then V versus T is decreasing here, so A is negative, the speed is decreasing. So you have to memorize the relation here between the graphs. Okay, now back to the exercise here. Okay, because we have V versus T an increasing line, so A is constant and positive, as you saw in the table. Now calculate the slope of the obtained graph. Slope is rise over run. Take the initial and the final point. It's y minus y over x minus x. Yani v minus v over t minus t. So 27 minus 0 over 30 minus 0. So هيدي point, its speed is 27, its instant is 30. This point is 0, 0. So 27 minus 0 over 30 minus 0. This is 0.9 meter per second squared. Now the other part of the question is, what does it represent? What does the slope of v versus t straight line represent? According to your acquired knowledge, you must know that it is acceleration. And if you forgot it, you have to check the unit here. This is meter per second squared, the unit of acceleration. So what does it represent? It represents the average acceleration. Okay, it represents the average acceleration. So Now calculate the distance covered by the train during the given 30 seconds. Because v versus t is an increasing straight line, then this is UARM, uniformly accelerated rectilinear motion. And if you go back to the table, you find that to calculate the distance in this case, it's half at squared plus vi times t here. Okay. So v initial is 0. Then half at squared, half times 0.9 obtained in part 3 times 30 squared. So it's 405 meters. Now calculate the instantaneous speed of the train at t equal 5 seconds. I did not ask you to get it from the graph. I asked you to calculate it. This means that you have to use the formula for UARM, which is v equal at plus vi. This is 0.9 times 5 at this instant plus 0. Its initial speed is 0, so 4.5 meters per second. Now if you want to verify your answer, you can refer to the graph and check 5. Is it equal to 4.5? You can find that yes, it will correspond to 4.5 meters per second.